So continuing from where we left off, now we're looking at free fall, which is a neat application. I'm kind of nuts about it. Example 2. A ball is thrown straight up from a cliff at 12.5 meters per second. It hits the ground at the base of the cliff after 6.85 seconds. How high is the cliff? So I gave you one acronym already. The acronym was DFIC, which stood for list your data, find a formula, insert the numbers in Crunch. By the way, you may or may not, want your yellow formula sheet in front of you unless you've got these 4 equations memorized. Some kids do memorize these 4 just because you use them so often. You don't have to. But if you find you have, great, because that's just less looking it up. But on a test, I would always look it up just to make sure I haven't memorized it wrong or something like that, right? How high is the cliff? So I've given you one acronym. The first acronym was DFIC. The second acronym, I don't think I've given you this one yet. Have I given you DULP? So in physics, when in doubt, you DFIC and you DULP. DFIC is list your data, find a formula, insert, and crunch the numbers. DULP is draw a little picture. And that's going to become very, very helpful as the questions get more and more complicated. Specifically, since this one is talking about a cliff and stuff like that, I think what we have is this. There's our cliff. What are they asking me to find? So I'm even going to go like this. D equals, I'll put a little question mark on the cliff. And it looks like we're standing right on the edge of the cliff, like with our toes basically right over the cliff. And what we're going to be doing is we're going to be launching something straight up with what kind of a velocity? Give me a second here. Interruptions. Hey, what's our launch velocity? What does this question say? And you, up, so I drew an arrow pointing up just to help me. So next to this arrow, I'll put a little 12.5 meters per second. And I guess what we're doing then, Zach, is it's going to go kind of up, and it's going to come down, and it's going to land. So we're throwing it straight up by sticking our hand out over the yawning chasm, throwing it straight up, and that way it can come down without hitting the cliff and hit the bottom. Is that okay? All right. Now let's DFIC. So what are they asking me to find? D equals question mark. What else do I know? Hey, what is that 12.5? It's the velocity. Which one? I think that's our launch, our initial velocity. I see a 6.85. What's that? Oh, seconds. There's one more thing that I know that I will never tell you. I don't know the final velocity. It's 0 after impact. So I'm glad you said that. When we talk about the final velocity when we're dropping an object, what we really mean is impact velocity, right when it hits. So yes, technically, after it hits the ground and has come to a stop and it's no longer in free fall, V final is 0, but then it's no longer in free fall. It's a completely different question. So I don't know final velocity, although I could probably calculate it. Yeah. Well, are we in free fall? Well, then A is what? Negative 9.8. There's our acceleration. And again, I think I said last time, but we'll say it again, we're ignoring air resistance. We're pretending in our magic physics world to make the math a little nicer, that all of our projectiles, anything that we're dropping or launching, is going to be like a solid steel cannonball that's really aerodynamic and isn't going to have much air resistance, okay? Hey, I'm looking for an equation that has D, VI, T, and A in it. I heard it, yeah? D equals VIT plus a half AT squared. And conveniently, the D is already by itself? Oh, I like that. Good gosh, I don't need to get the D by itself. I can plug and chug right here. Cool. D is going to be VI, 12.5. T, 6.85 plus 0.5, negative 9.8, 6.85 squared. And you're going to get an answer that at first looks a little weird, but if you think about it, it'll make sense. And again, I think I've done my it's well worth practicing on your calculator rant, yes? Because it's well worth practicing on your calculator. Every year I got one kid who's clearly been, or two kids that have been just sitting around. Yeah? Where would yours be, oh pray tell? You left it in your locker. Got a phone? So let's see what I get here. 12.5 times 6.85 plus 0.5 times negative 9.8 times 6.85 squared. Those of you that have crunched this, what do you notice that's a little strange about your answer? Mark? Negative. Wait a minute. Did we end up above or below from where we started? Nature is actually telling you, hey, I know you're standing on a cliff and I know you ended up below from where, it's telling you that. In fact, really we didn't find a distance, we found a displacement. Right? Negative 144.2. Well, I'm going to write down negative 144.3 and then I'll go sig figs. So let's see. And I guess since it's a displacement, I'll even add the vector sign. D equals negative 144.3. How many sig figs should I really go to? 3. So I'll say negative 144 meters. Now, that's the displacement, but technically I didn't say find the displacement. What did I ask you to find? I said how what? Technically, and I'm not going to take marks off, but technically height's a scalar. You don't say, oh, that mountain is negative 144 meters high. It's 144 meters high. And even when you're standing on the top, you still don't say, oh, look, the ground, you still talk about heights in positive as English. So technically the word height is a scalar. I won't take marks off, but Sabrina, I can't just leave it like that. I have to fix it. Is that okay? But I do like that negative, actually. It's kind of neat that nature, that the universe is saying, yeah, I know you're standing up and you're looking down. Kind of cool. Before we turn the page, you have some room at the bottom here? Cool. Find the impact velocity. Find how fast it's going when it hits the ground. Now, from now on, Zach, I'm not going to call it the impact velocity. I'm going to say find the final velocity, and I'm going to expect that you clue in. Mr. Dueck doesn't want me to say 0. Because that's a boring question. Come on. Yes, I know everything after it hits the ground has a velocity of 0. When I say final velocity, Jake, what I really mean is the final velocity while it's in free fall, the split second when it hits the ground. Is that okay? So sometimes I will say impact velocity, but sometimes I'm just going to find the final velocity. Oh, okay. So I'm looking for an equation that has V initial, T, A, V final. It can have distance, but I'd prefer to avoid using distance if I can, because in case I got the displacement wrong, then I'm going to get the V final wrong, so I'll avoid that if I can. Is there an equation that has V initial, T, A, and V final? Yeah, Chris?
V final equals,
oh, and the V final's by itself already? Yeah. Oh, nice.
Equals VR plus infinity.
Where VI was 12.5, A was negative 9.8, T was 6.85. What do we hit the ground at? Do you get negative 54.63? Yeah. What's the negative telling me? Oh, it's giving me a directional component. It's saying, by the way, I know you're going down. So if you're ever launching something straight up from a cliff, and you get a positive velocity, it means you found it when it was still on its way up. And that may happen. I may say, hey, how fast is it traveling after 1 second? If you get a positive answer, you'll know after 1 second it's still on its way up. In fact, at the top, for a split second, how fast is it traveling at the top? Huh? 0. We can use that as well to figure out, hey, when does it get to the top? We can do all sorts of stuff. We'll start looking at some of those applications. Anyways, negative 54.63. Come on, pen. Was negative 54.6 meters per second. Okay. Cole, by the way, let's suppose this was a test question. It might be. And I finish the test. I could actually, don't write this down, I could actually now use V final squared equals V initial squared plus 2AD. I could solve for D using that equation, and if I get the same answer as I got for A, hey, I know A has to be right, and I know B has to be right, because I used my answer from B to find my answer from A using different information. There's lots of different, you're going to find very rapidly now, you'll often have 2 different approaches you can use. Hey, I can check my answers quite nicely. If I get the same answer both ways, yay! Nope, that didn't quite work. Turn the page. Example 3A, or next page over, is it? Not turn the page, next page over? Okay. A ball is thrown straight up with a velocity of 32 meters per second. By the way, what if I was standing on a cliff? We're not standing on a cliff here, it doesn't mention a cliff. But on the previous question, what if I was standing on the cliff and I threw it straight down? But how could I show that in my initial velocity if I threw it straight down? I would make my initial velocity what? Negative. And everything still works. The universe will then, as long as you do the physics right, will understand what's going on. Okay. Here, we're standing on the ground. We're throwing it straight up with a velocity of 32 meters per second. Okay. A, how long does it take for the ball to reach its maximum height? What do they want me to find in part A? Oh, T equals question mark? We're not on a cliff, so I don't think I'm going to defic this time. I don't think I'm an adult. I'm not going to draw a little picture. What else do I know? VI is 32. When I throw something, is it in free fall? Then what's its acceleration? How can it be accelerating negatively but still traveling positively up? It's slowing down, yeah. Again, one of the things that kids get mixed up, non-physics nerds get mixed up, they want to say velocity and acceleration always have to be in the same direction. Actually, no, anytime you're slowing down, I guarantee your acceleration is in the opposite direction of velocity. So A, negative 9.8. That's not enough. You may recall, Brandon, the other day I said, I always need 3 things to find the 4th. Right now I only know 2 things to find a 3rd. Not enough. Every one of the equations in this unit has 4 variables. What else do I know? I mentioned this a few minutes ago. At the top, for a split second, how fast are we traveling? Are you saying I know V final? Okay. I'm looking for an equation that has T, V initial, A, and V final in it. There is one. Oh, and I guess it can't have a D, because I don't know what D is. Although in part B, I'm going to be finding D, I think. Alex. VF equals VI plus AT. Alex, what am I trying to get by itself, my friend? All right, you ready? So here's the T on this side. Eventually I'll deal with the A, but I'll deal with that last. I'll deal with the VI first. How can I move that VI over, my friend? What's it doing? Adding, subtracting, multiplying, or dividing? So how will I move it over? So if I hear you correctly, you're saying it's going to be VF minus VI. And then what would I do with that there? A. There's a new equation. Do you need to memorize that one, Alex, or can you, in 1 second from that original, derive it yourself? Okay. In fact, honestly, my goal in about a week, and I don't know if we'll get there, but I have with most of my classes, my goal in about a week, Alex, is going to be this. You'll say VF equals V. I'll say, stop. Can you, in your head, rewrite the equation in your head and just give me the new equation? And you'll say, oh, T equals VF minus VI over A. In fact, we'll stop writing this line eventually. We'll go straight to this second line, and I think that's a good thing. And if you don't get there, that's fine. But I'm going to try and push you out of your comfort zone. We're a little nerdy. Hardcore nerdy. T equals, now it's plug and chug. VF, 0 minus VI, 32, divided by negative 9.8. By the way, take a look at this for a second. Time, scalar or vector? Scalar, so it should be a positive answer. I was a little worried at first because I saw that negative 9.8. I thought I'm going to get a negative, but wait. The top also works out to negative, doesn't it? See it? I get a negative divided by negative, which Alex is a. The universe is saying, hey, I got your back. Kind of like that. Zero minus 32. Oh, more than one number on the top, brackets around the top. Yes. Negative 9.8. You know what? It takes 3.265. I'm going to write 3.265, and then I'll do sig figs. 3.265. How many sig figs? I guess technically 3.3 seconds. Okay. What's B asking me to find? Maximum height. By the way, in this question, is the maximum height above us or below us? Should I be expecting a positive displacement or a negative displacement this time? Positive. So if I get a negative, I've goofed, right? So there's built-in error checks here if I stop and think about the physics a little bit. Oh, you guys said I'm finding D equals question mark. So I'm looking for an equation that has VI, A, VF, and D. It can have time, although if I can avoid it, maybe I don't want to use it. Carly says VF squared equals VI squared plus 2AD. Can you get the D by itself without me coaching you at all? Okay, worth a try. Ready? See the D? So I'm going to move everything to this side, right? So the VF squared would certainly drop down like a domino, yes? And then I got to move this over. And then I got to move this over. Right? You memorize that if you want. Don't, please don't. It's going to be 0 squared minus 32 squared all over 2 times negative 9.8. More than one number on the top, brackets. More than one number on the bottom, brackets. This is where, by the way, my friend, that cheap calculator, it makes it awkward to see the brackets. That's my own. It's nicer if you can actually see bracket, close bracket, bracket, close. It's easier. Just saying. I got Jake to get a better calculator. Now I'm going to get Jake to get a better calculator. Oh, a little confusing. 0 squared minus 32 squared, close bracket, divided by bracket, 2 times negative 9.8. You get 52.24489, 52.2. Actually, I guess to 2 sig figs, 52 meters. Half a football field. That's a pretty good chuck, actually. Straight up? Yeah, that's actually not bad. By the way, there is another way I could have done this, and this might be a way I might check my answer. I could have used that. The only issue is then I'm using my time answer from part A. But this would be a nice way, if I finish a test early, for me to check both my answer for part B and for part A. Because if I quickly go 32 times 3.26? What did I say the time was actually? 3.265? So if I go 32 times 3.265 plus 0.5 times negative 9.8 times 3.265 squared. And if I get an, whoop, did I type this in wrong? Negative, Mr. Dueck. Thank you, Carly. I did type it in wrong. If I get an negative, Mr. Dueck, come on. I know what happened. The negative didn't want to. Okay, negative. I had to hit that 3 times there. Okay, let's try that again. If I get an answer close to 52.2, I know I'm right both ways. So you could always use that as a check. The only way that I could have got that answer is if A and B are right. That's kind of nice to know. C. What's C asking us to find? Didn't we already find time in part A? Oh, no, we only found the time to the top. How can I find the total time of flight? Sorry? Well, first of all, what are we being asked to find, Olivia? Let's go T equals. I know A is negative 9.8, yes? What was VI? What was VI? It was... what else do I know? Believe it or not, I know this. I know this. There's a saying. The saying goes, what goes up must come down. If I launch at positive 32 meters per second, and I'm not standing on a cliff, if I leave the ground at positive 32 meters per second, you know what I hit the ground at? Negative 32 meters per second. Because whatever acceleration you lost and then you reach the top, you start accelerating back down. It basically reverses what's just gone on. So I can actually say that. Now, Dennis, I could not say that on the cliff example here, and the reason is it would go up at 12.5 meters per second. When it came back down, right when it got level with the cliff, it would be at negative 12.5 meters per second. But does it keep falling? Does it keep speeding up? Okay, so I can't make, you got to be careful, because a lot of the times kids always just want to say, oh, V final is negative V initial. Well, no, not if you're on a cliff. But if you're on the ground and ending up on the ground, if you're ending up at the same height as you started from, what goes up must come down. So I'm looking for an equation that has time A, VI, and VF in it. I think this one. Resonance, also good physics, but a totally different branch we don't look at. How would I get the A by itself? What will I do with the VI? Minus it, and then what will I do with the, how will I get the T by itself? What will I do with the VI? Minus it, what will I do with the A? Now, I know you have that same equation just sitting up up there, but in some ways it's almost easier to rewrite it in your head than even bother looking up. Almost, I hope. We'll get there. So time is going to be, the V final would drop down. I would subtract the V initial over. I'd divide by the A. Negative 32, take away 32, all over negative 9.8. Negative 32, take away 32, divided by negative 9.8. I get 6.53 seconds. Oh, I guess 2 sig figs, right? Does anybody see another way we could have done this? Yeah. Kylie, got to be careful here. First of all, I got to be fussy. You said distance. What you really mean is displacement, yes? Okay. How high are you when you leave the ground? When we launch, how high are we? It's a trick question. 0. How high are we when we end up back on the ground? You know what our displacement is, actually? 0. You could have also said, hey, for what it's worth, don't write this down. I always talk about this, but you're going to see if you did do that, you're going to run into a problem. See, if you did that, well, let's see. What equation has time, A, V initial, and D in it? Don't write this down. You would probably say, hey, Mr. Dueck, this one. But when you try and get the t by itself, the problem here is there's a t and there's a t squared, 2 variables. This is, I think I said, and if I didn't say it the other day, I'll say it now, this is both the most useful equation and the toughest one to manipulate. This is right now, temporarily, a dead end until you guys learn how to solve quadratic equations, which most of you will be doing in Math 11. Some of you in grade 12 may recall how to solve a quadratic. But I can survive without that. So I could, this is true, but you're going to end up in kind of a yucky dead end. There is another way, though. How could your answer from part A tell you the answer for part C? What did we find in part A? Sorry? How long it took to go all the way up? Care to guess how long it takes to come all the way back down? The same. You could actually have taken your answer from A and doubled it. In fact, if I go 3.265 times 2, is that really, really close? We've rounded off a bit, but is that what we got in our answer for C? That works just fine, and you can feel free to do that. Just make really, 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 really sure that you got part A right. I didn't mind doing it without using my answer from A because now I kind of have done a built-in error check. The fact that I doubled A and I got my answer for C, I know both those must be right. Have to be. It's kind of nice. But that works. Oh, but not when you're on a cliff. Because when you're on a cliff, it's going to fall for longer than it went up because it's going to go past your feet and keep falling for a while. So cliff, trickier. But ground to ground, lots of little shortcuts. Hey, what is D asking me to find? Impact velocity. What goes up must come. I see some of you looking skeptical. Okay. Look up. Your displacement is 0. I'll get 32 squared plus 0. That gives me VF squared. How would I get rid of a squared? You didn't get negative 32, Mr. Dueck. Well, I sort of did. The only tricky part, this equation here, I don't know if you ever noticed, I've never put vector symbols on that equation there, I don't think. That equation actually is a scalar equation. You have to add the directions to it. And you're never going to run into that because instead you would just say what goes up must come down, which is way, way faster. But for what it's worth, you can crunch the numbers and show that it is coming back at exactly the same speed. E. We already answered this. Kylie, what's the displacement of the ball once it hits the ground? Yep. Oh, displacement, vector. Its distance is whatever the height was times 2. That's how far it's traveled, but that's not, it's a displacement. That's your change in position. How high were you when you started? 0. How high were you when you ended? 0. What's your displacement? 0. Okay. A baseball, last one. A baseball is thrown straight up. I think this is the last one. Yeah, it is. It leaves the thrower's hand 1.6 meters above the ground, with a velocity of 16.2 meters per second. Okay. So here, we're doing this. That's about 1.6 meters. We're doing that, throwing it straight up. Okay. At 16.2 meters per second, fairly quick. How long will it take for the ball to reach the top of its path? Okay. What are they asking me to find here? What else do I know? When it leaves my hand, is it in free fall? Yeah, so what do I know? Negative 9.8, right? I'm not going to include that in the question anywhere. I'm going to expect you to fill it in yourself. What else do I know? What's VI? What else do I know? What's VF at the top for a split second? Okay. You'll notice I haven't used that 1.6 meters yet. Don't need it. I'll probably use that later on, but it doesn't seem to play a part in this. Hey, is there an equation that has TA, VI, and VF in it? Well, I think there is. I think it's this one. Right? I think. Maybe. Noah, how can I get the T by itself? I'll deal with the A last, but I got to move the plusy minusy things over. How can I move the VI over? Minus it and then divide by A. So are you saying that time is going to be, the final would drop down like a domino, you would minus the V initial and divide by A? Smarter than you look? No, I came out right. Make that a compliment. So it's going to be 0 minus 16.2 divided by negative 9.8. Zero minus 16.2 divided by negative 9.8. Do you get 1.653061 1 point? I'll write 1.653 and then I'll do sig figs. So 1.653. How many sig figs? Well, 3 here. Technically 2 here, but you know what? That's a given piece of data. That's a constant. So I would accept 2 or 3 to be technical here. It's actually 9.8, I think, 06, which is technically 9.81, but the fact that there's a 0 there before that, we just kind of go negative 9.8 is our rule of thumb. So I'll go 1.65 seconds. I'll go with the 16.2 piece of data that they gave me. Had 3 sig figs. I'll go 3 sig figs. Okay. B. Jacob, what's B asking me to find? Which variable is that? Oh, D. I don't think anything else has changed. I'm not going to read dfic. I have my data right above me in part A. So I'm looking for an equation that has D, VF, VI, and A. Is there one? I think there is. VF squared equals VI squared plus 2AD. I could use D equals VIT plus a half AT squared, only that would be using the time that I got from part A. I'll probably use that to quickly check my answer later on and see if I'm right, if I have time on the test. Question, Chris?
No,
Did I write something wrong? I might have.
I know, just fine.
You're good?
Yep.
So, all right. Ready, Brad, my friend? We're going to get the D by itself. Guarantee it. What side of this equation here is the D on? Left side or right side?
Right side.
So the VF squared is going to drop down like a domino, right?
Yeah.
No, left. Right? I mean, yeah, okay. I'll deal with the 2A last. I need to deal with this. How will I move this over?
Subtraction.
Darn right. How will I move the 2A over?
Divide.
The whole thing? It's going to be 0 squared, take away 16.2 squared, all over 2 times negative 9.8. Zero squared, take away 16.2 squared, all over bracket 2 times negative 9.8. Did I type something in here wrong? I squared outside the bracket because I'm getting a negative, and I know I ended up above from where I started from. Thank you. That's got to go there. And like I've said, there are lots of built-in error checks. I went, wait a minute, I got a negative displacement. I'm pretty sure I'm above from where I stood. So there's built-in, if you type something wonky on your calculator and you pay attention, often you'll catch it. Did you get 13.3897, 13.4? Or am I wrong? Yeah? 13.4 meters? No, yeah? Okay, don't clear it. Let me come look. Okay, by the way, if you're getting the wrong answer and you try it again, you still get the wrong answer, don't clear it, call me, and it's going to be some sloppy calculator mistake, I guarantee it, and it's probably, I can fix that. This time, thumbs up? Oh, okay. 13.4 meters. Why is that wrong? Because it is. Yeah.
The ball left his hands 1.6 meters above the ground.
Did you hear? This time I added an extra little twist. I didn't. In the previous one, it was as though you were laying on your back on the ground and throwing it up right from ground level, which we never do in real life, so I added a bit more realism. Yeah, it was about 1.6 meters off the ground when it left your hand, so H is going to be 13.4 plus 1.6, which I think is a very nice round 15.0 meters, yeah? Okay. That's not very high. C, what's the final velocity of the ball when it reaches its original release point? When it gets back to the height that it was launched from, what goes up must come. So what's its velocity?
Negative 16.2.
Is that what it hits the ground at? No, you know what? It falls a little bit further. It probably hits the ground at about negative 16.4 or negative 16.5. That could actually, if I was bored, actually calculate and figure it out, but I'm not gonna. Not gonna. Okay. Free fall. Lots of examples, lots of applications, lots of stuff we can do with this. Homework. So the first part of your homework is, I called it quiz number 3. So describe the position of A and B using 0 as a reference point. We're talking about displacement, for example. So what would you say the position of of A was? Think positives and negatives. We're starting off, actually, we've already moved a couple of days beyond that. So ideally, you'll find some of this quiz pretty obvious and boring. Define a scalar. Give me an example of a scalar. Define a vector. Give an example. We did that in our notes quite a while ago already. Define displacement. Suppose I run 100 meters in 9.8 seconds, get my average velocity in meters per second, and then convert it to kilometers per hour. Suppose I run an average velocity of 6.3 meters per second for 45 seconds. How far will I run? So no acceleration. How long? Hey, that sounds like a time question. What does the slope of position versus time graph represent? You might have a physics teacher who occasionally went on a rant about that. I don't know. Turn the page over. So now we're doing some interpreting of graphs. This is back when we were still dealing with graphs. So the graph below is the position versus time graph for a short car trip. Find the average velocity for each part. So how many marks is this worth? 3 marks, because there's 1, 2, 3 little lines that you can find the average velocity of. It's a position time graph, so the velocity is on there somewhere. I'll let you remember how that worked. Number 10, this is a velocity time graph. Describe the motion of the runner. Tell me what's going on right here. Tell me what's going on right here. Tell me what's going on right here. And then number 11, I like this question, I like this question, I like this question. Sketch velocity time graphs for the graphs below. So that's your first bit. Okay. You know what? 25 minutes left. I think I'm going to give you that, and we're going to be watching a fairly long video, so you can watch the video and then work on the quiz. I'm going to pause there.